pretty peculiar that as soon as I alerted the JPL horizons for the coincidence, the numbers were revised.
The shock did not come with alarms or flashing warnings. It came with silence, followed by disbelief. XRISM's detectors picked up a signal that should not exist. A faint X-ray glow appeared in the data stream, steady and unmistakable, coming from a region of space that was supposed to be dark. The object responsible was already moving away from the sun at extreme speed. It was an interstellar comet, 3Y Atlas, an outsider that should have been quiet, cold, and fading. Instead, it was glowing with high-energy radiation. At first, engineers suspected a mistake, a sensor glitch, a stray solar flare, background noise slipping through calibration filters. But the glow did not vanish. It persisted. It sharpened. And as new frames arrived, something unsettling became clear. The X-ray emission was moving perfectly in sync with the comet itself. This was no artifact. The halo surrounding the object was enormous, stretching nearly 400 kilometers across. That scale was far beyond anything random or accidental. Background radiation does not form clean structures. Instrument errors do not follow objects across space with precision. Yet every frame showed the same result: a vast, ghostly X-ray cloud locked onto the comet like a shadow made of energy. Scientists began ruling things out, one by one. Not Earth's atmosphere, not the Milky Way, not scattered solar radiation. The conclusion was unavoidable and deeply unsettling. For the first time in recorded history, an interstellar visitor was emitting X-rays. Neither Oumuamua nor Borisov, both studied intensely, had ever done this. They passed through silently, revealing little and leaving fewer answers. But 3I Atlas was different. This object was not just passing through the solar system, it was reacting to it. And that reaction was happening right now. The data suggested active, high-energy processes unfolding around a body that formed around another star, billions of years before the sun existed. Something ancient was colliding with something familiar and releasing energy no one expected to see. What terrified researchers most was not just that the signal appeared, it was where it appeared, how large it was, and the growing realization that this was only the beginning. Because as scientists prepared to analyze the structure of the glow, a far more disturbing question began to surface, one that would challenge everything they thought they understood about interstellar objects and what happens when they encounter our star. And the next set of data would make that question impossible to ignore. The signal refused to behave. Hour after hour, XRISM kept watching, stacking exposure time far beyond what should have erased noise. Instead of dissolving, the structure sharpened. What first looked like a faint blur hardened into a shape, smooth, balanced, and centered perfectly on the comet's core. By the 17th hour, denial was no longer possible. Something real was there, and it was growing clearer by the minute. The emission was not a point. It was not a streak. It was a halo. A wide, symmetrical shell of X-ray light surrounded the nucleus, expanding outward in all directions. Its measured size stunned the analysis teams. 5 full arc minutes across, an absurd scale for an object at that distance. When converted into physical space, the implication hit hard. The halo spanned hundreds of thousands of kilometers, rivaling the distance between Earth and the Moon, yet compressed into invisible, high-energy radiation. That kind of structure did not come from chance. Engineers pushed the instruments harder. Filters were adjusted. Background models were rerun. Calibration checks were repeated again and again. If this were noise, it should have weakened. If it were contamination, it should have shifted or smeared. Instead, the opposite happened. The glow intensified, stabilizing into a clean, unmistakable signal. One possibility after another collapsed. Milky Way background radiation was ruled out first. The spatial profile was wrong. Earth's atmospheric X-rays came next, impossible at that geometry. Solar scattering failed every test. Detector artifacts didn't match the symmetry. Every known explanation fell apart under scrutiny, leaving only one conclusion standing. The signal was moving. Frame after frame, the halo followed the comet with surgical precision. As 3I Atlas advanced across the sky, the X-ray emission advanced with it, locked in place, perfectly centered, never lagging, never drifting. This was not something the comet passed through. This was something bound to it. That realization changed everything. Debris fields don't behave like that. Reflections don't track motion with that accuracy. Random interference doesn't maintain symmetry across 17 hours of observation. What XRISM was seeing was a living interaction, energy being produced in real time, driven by an active process. An interstellar object was not just present in the solar system, it was reacting to it. The halo's uniformity raised deeper concerns. The structure was too clean, too organized, suggesting a large, dense region of interaction. That meant the comet's surrounding cloud, its coma, was far more extensive and energetic than expected. Whatever materials were escaping its surface were engaging the sun's influence on a massive scale. This was no passive flyby. 3I Atlas was exchanging energy with the solar environment in a way no previous interstellar visitor ever had. Oumuamua showed no such behavior. Borisov never produced anything close. This object was different, chemically, dynamically, and now radiatively. And the most unsettling part was timing. If the halo looked this large after 17 hours, what had it looked like before observations began? How strong had the interaction been when the comet was closer to the sun? When X-ray observatories couldn't safely point in its direction? The data suggested this was not the beginning of the event, but a late snapshot. Scientists realized they might be watching the fading edge of something far more extreme. The rules for interstellar objects had just been rewritten, but the ink was still wet, and the next discovery was already forming. Because now the question was no longer if the sun was interacting with alien matter. It was how violently, and what exactly was colliding inside that glowing halo, a mystery that would only deepen as investigators turned to the physics driving the emission itself. The danger did not come from an explosion. It came from contact. As 3I Atlas plunged deeper into the sun's influence, its surface began to fail. Ice that had survived billions of years in interstellar cold started to vaporize almost instantly. A massive coma erupted outward, gas and dust flooding space around a nucleus older than the solar system itself. This was not a gentle release. It was a violent awakening. And the moment that cloud formed, it entered a battlefield no interstellar object had ever been observed surviving under direct scrutiny. The solar wind hit next, invisible, relentless, and moving at extreme speed. Streams of highly charged ions slammed into the comet's expanding atmosphere like a particle storm. These ions collided with atoms that did not originate here, matter forged around a different star, under different conditions, long before the sun existed. The encounters were brutal. Electrons were ripped away in fractions of a second, leaving atoms unstable and exposed. Then, just as suddenly, those electrons snapped back into place. Each recapture released energy. Not heat, not light visible to the eye. X-ray photons, sharp, penetrating, and unmistakable. XRISM saw it clearly. The spectrum lit up with precise signatures: carbon, nitrogen, oxygen. Familiar elements, but behaving in unfamiliar ways. They burned brighter than the surrounding cosmic background, forming an X-ray halo that should not exist at that distance, at that intensity. The process itself, charge exchange, was known. Scientists had modeled it for decades. But the source material shattered expectations. This was not solar system ice. This was alien chemistry responding to the sun in real time. For the first time in recorded history, the sun was not just illuminating an interstellar visitor, it was reacting with it. And that realization triggered a deeper fear. Because if this interaction looked familiar only on the surface, if the physics worked but the response did not, then something inside 3I Atlas was different. Something uncalibrated. Something models were never designed to handle. The X-rays were not just emissions. They were signals of a mismatch between known solar behavior and unknown interstellar matter. And that raised a question scientists were not ready to answer yet. If this is how alien material reacts to our star, what else does it do as it moves through the solar system? That question would not wait, and the next discovery would make it impossible to ignore. The fear did not come from the X-rays alone. It came from where they came from. Until now, X-ray emission from comets followed a rule scientists trusted. It only happened with objects born inside the solar system. That rule was established in 1996, when comet Hyakutake surprised astronomers with X-ray light. But Hyakutake was familiar. Its ice, dust, and chemistry formed around the same sun that produced the solar wind striking it. 3I Atlas did not. This object was forged somewhere else, around another star, in another stellar nursery, billions of years before the sun even existed. Its chemistry matured under unknown radiation, unknown magnetic fields, unknown stellar violence. Yet, when it entered the sun's domain, it reacted immediately, violently, and not exactly the way models predicted. Some aspects of the X-ray signal matched theory. Others did not. The emission strength implied a coma far denser and more reactive than expected for an object moving this fast. The interaction suggested atomic structures that should not respond so efficiently to solar wind ions. And the rate of charge exchange hinted at material properties scientists have never tested in a solar system environment. Then came the velocity data. 3I Atlas was moving faster than any interstellar object ever recorded, faster than Oumuamua, faster than Borisov. Its trajectory showed no hesitation, no slowing, no gravitational capture. It was not visiting, it was passing through. Age estimates only deepened the unease. This object formed before the sun ignited, before Earth existed, before the planets settled into stable orbits. It carried matter older than everything humanity has ever studied up close, and that raised the question no one wanted to ask out loud. If an object like this can enter the solar system, light up in X-rays, and nearly go unnoticed, how many others have already done the same? How many interstellar bodies pass through the sun's influence every year without detection? How many interact with solar plasma, shed material, alter space environments without instruments pointed at them? And how many produce effects scientists have never learned to look for? Because now, one fact is unavoidable. The solar system is not a closed system. It is being sampled by interstellar matter in real time. And if this is what happens when alien material briefly brushes against our star, the next question is far more unsettling: what happened when 3I Atlas came even closer, before anyone was watching? The X-ray emission did not begin when scientists first noticed it. That realization hit like a shockwave through the data teams. By the time XRISM detected the glow, the event was already fading. For weeks, possibly longer, 3I Atlas had been interacting violently with the sun, completely unseen. Not because the instruments failed, because humanity was looking in the wrong direction. As the comet rushed toward perihelion, It slipped behind the sun's blinding glare. X-ray observatories could not point directly at it without risking damage. At the moment when solar forces were strongest, the comet was effectively invisible. Behind that wall of light, something extreme was happening. The solar wind was at maximum intensity. Charged particles were slamming into alien material at speeds never observed before. The coma was expanding, ionizing, reacting, and no one could watch. Then, quietly, the geometry changed. As 3I Atlas drifted just far enough away from the sun's position in the sky, XRISM was finally able to lock on. And the signal appeared instantly, not gradually, not weakly, fully formed. That timing terrified analysts, because it meant the X-rays did not start at detection. They were already there, waiting to be seen. By the time humanity noticed, the comet had already passed through its most intense solar encounter. The violent peak had likely already occurred. What XRISM captured may only be the cooling aftermath of a far stronger event. Models now suggest the missing phase could have produced X-ray emissions far brighter than anything recorded. Denser plasma, more violent charge exchange, possibly reactions that would have rewritten existing comet physics entirely, but that data is gone. Hidden by the sun, blocked by geometry, lost without warning. Scientists are now left with a chilling possibility. The most extreme interaction between the sun and interstellar matter may have already happened, unobserved. And if that is true, then the signal we see now is not the beginning of the story. It is the echo. Which raises the next question. If this was only the aftermath, what does 3I Atlas do next as it moves farther away? There is no slowing it down now. 3I Atlas is already past the point of hesitation, accelerating on a hyperbolic path that guarantees one thing with absolute certainty. It will never come back. No orbit, no return pass, no second chance. What scientists are watching is not a visitor settling in, but a fugitive already escaping. December 19th is the last moment that matters. On that date, the interstellar comet reaches its closest point to Earth, about 270 million kilometers away. In cosmic terms, that is close enough to study in detail, but far enough that every photon counts. After that brief alignment, geometry turns against humanity. The object angles away, light weakens, and the signal begins to thin. Not gradually, but hour by hour, its coma is reshaping itself under solar pressure. The plasma tail flickers, stretches, then fractures. Brightness spikes appear where models predict stability. Subtle spectral shifts hint at chemical reactions still unfolding after perihelion. Whatever happened near the sun did not end. It propagated outward, and the effects are only now becoming visible. Each new data set raises more questions than it answers. The X-ray emission detected earlier should be fading by now. Instead, residual activity persists longer than expected. That delay suggests deeper reservoirs of volatile material, or interaction layers thicker than anything previously measured in an interstellar object, and that changes everything. If 3I Atlas carries complex chemistry this deep into its structure, then interstellar space may be seeding star systems far more aggressively than assumed. Models of planetary formation, chemical transfer, even early prebiotic environments are suddenly under pressure. But the clock is merciless. Miss a night of data, and that angle is gone forever. Lose one spectrum, and a reaction pathway vanishes from history. There is no rewind, no recovery mission, no future intercept. This is it. The only recorded moment when the sun exchanged X-rays with matter from another star, and humanity was watching, or almost watching. Because the most unsettling possibility still hangs in the background. What if the strongest interactions are still coming? What if the delayed emissions mean something inside the comet has not finished reacting yet? As 3I Atlas races away, instruments keep recording, but the signal is thinning, the geometry worsening, and time collapsing fast. And just as scientists prepare for the final data drop, one question refuses to go away. What happens if the comet hasn't finished responding to the sun? And the last thing it does before disappearing is something no one is ready to explain.